Basically, over the ensuing years, our students have treated both this room, the Damascus Room, and begun treatment on the Syrian Rooms. And this is Richard on the right with Kirsten Travers, who was one of the interns who spent a summer here, who started the project of the Syrian Rooms. And today I'm going to drift into the other rooms as well. I can't stay here partly because my personal involvement is in the other rooms, and partly because I think there's some interesting contrasts and comparisons between the two rooms. So this, after Richard gave his talk and the summer was planned, the students came back, and part of what they did that summer was they took quite a few more samples, about 40 more samples, which went back to Winterthur and were eventually analyzed. And so I just want to go over the basic findings that they discovered about this room, and we'll do the same with the Syrian Rooms. So this is, I think, an interesting image because you see in the full image that there is actually an underpainting showing in a loss. This is not a loss we made, this is just a flake in the room. And you can see an earlier paint scheme, which is maybe not exactly what was there before, because clearly there's a jami in the upper layer, and underneath looks like it might be a decorative paint layer without any jami. But in any case, the cross-section on the right illustrates that layering pretty well, where on the top you see the tin leaf that would be on top of the ajami, and at the very bottom you see a very thin layer, which is the original presentation surface. And on the right, in ultraviolet light, you can see this bright line here, which is the varnish, which would represent the presentation surface of the original paint layer. I'm not sure that this is exactly from the same sample, but it's a similar kind of place where ajami was painted over an original paint. So he did several cross sections, and the findings basically were that it was a tin leaf. Analysis was done for that, and he did use some fluorochrome stains to characterize the binding media, but it was not very conclusive, only that he often found protein and resin, both protein and natural resin, in the varnish layers, which speaks to it being kind of an emulsion that might present a little bit more of a cleaning problem than just a plain natural resin varnish. So I think while the initial study was going on, there was the thought that this room might be cleaned, the varnish might be removed. This is an analysis of the tin, just to show that it was a tin leaf, because on first look you might think that the leaf in here would be gold, but it's since been discovered, or it's commonly known now, I think, that the calligraphic panels are gold, gilded with gold, and a lot of the other metal leaf is tin. And he also did Fourier transform infrared spectroscopy to look at the binding media, which is a little more definitive than with the stains. And I'm not going to bore you with the details, but on the bottom would be the gesso layer from the ajami, and there's a peak there around 1100 that would be for calcium sulfate, which is gypsum, which is and on the top in the varnish layer he found proteins and functional groups that would be consistent with a natural resin varnish. So there did seem to be a lot of admixture of materials. Sometimes you're finding oil and gums and proteins, but primarily a typical gesso layer with calcium sulfate and glue. This sample is really illustrates why this room is so dark, and it's there's a lot of panels that the Anka has said, well, this of course should be blue, and this is a cross section on the left, and it's not easy to see, but these very big chunky blue crystals are probably smalt. It wasn't actually analyzed in this room, identified in this room, but on the right in ultraviolet light everything's kind of bright. On the top, that bright white layer is the varnish layer fluorescing, but the varnish itself in normal visible light is really dark and muddy. So instead of seeing a blue paint layer, you're seeing brown or black. So when they took the sample, it was labeled black. And that's very just illustrative. This is a good image. We have here a very, very thin green paint layer on top of a gesso or maybe a jami base. And all of this is varnish, maybe 4 or 5 layers of varnish. And probably dirt. You see the dark lines in between is probably dirt that's settled between the coatings of varnish. So that's why this room is so dark. And this is an interesting image too, because you see some of those later layers of varnish are dripping down. Over there you see UV dripping down through the cracks and into underneath the paint, because it was quite aged and cracked by the time that layer was added. So the project here was 4 phases. We considered the initial work that Richard did, the phase 1. Phase 2 was an assessment and documentation, because it was decided that everyone recognized that this was a pastiche. So that one of the goals of the project was to document it in a way that would provide Shangri-La with something to move forward, to assess what it was, what parts were original, what parts were added, and then to document the conditions so that Kent can now come in here with a sheet and say, oh, there's a flake and that wasn't flaking before, and he can say, oh, and next to it they use this consolidant, so I'll use this consolidant. So hopefully this is going to become a really useful document now. And our first interns were Natasha Loblick and Amelia Bagnall, and what they did was they took very high resolution images taken by Franzen in '99, I believe, or maybe even closer to the time.
Yeah, it wasn't Franzen actually.
Oh no, it was a different name, right? Yeah. But it was the '99 photographs. They put clear sheets over them. They marked, color-coded the photographs with different condition issues and structural things, and I'll show you some examples. And then they had to enter that data into Adobe Illustrator with, I think they either used a mouse or you can use a digitized tablet. And then they produced a document. So here's the original photograph, which is then desaturated, so it's just black and white. And then these colors, and they have a key that show the different, and they used layers for loss, a layer for acute need of consolidation, because they were setting this project up for the next team of interns to come in and treat it. And then they did work on the structural differences so that the museum, that Shangri-La, would have a record of that they could. And this is what Keelan showed us before. And one thing I wanted to point out are the little dots up there are actually the sampling locations for the cross-section samples that were taken. So you can go back always and correlate those to the original. The second phase was the following summer, I believe, and two interns, Brett Headley and Louise Orsini, came and did basically glued down all of the flaking paint. And this is one of the things that I found kind of interesting about this. I remember talking about this, thinking about this, discussing it, because at the same time the Met was starting to work on the Nur al-Din room, and I know they were using sturgeon glue, and in most museums and in a lot, even in myself in a museum or in private practice, if I have a flaking gesso layer, I'll often use an animal glue, a collagen-based glue from fish or from a horse or some because it is the same material that the ajami is made from. It has good affinity to it, it sticks to it. The water softens the glue. It really lets you do a lot with it. But here, when they did the test, it was so humid that the glue never dried, and we figured it was going to be a bit of a problem with pests. So, so choices were made to use synthetic materials, which are, to some extent, also driven by the conditions here. Because in this case, this room was closed, and they could put big fans in. So the consolidants they chose were using solvents you might normally not want to expose, the public to. They were using mineral spirits and a little bit of aromatic compounds. And we found when we went to the Syrian Room, we made different decisions because that room remained open to the public at the same time. But again, one of the things that Brett and Louise did was they also took some samples of the fiber fills that are often stuffed between into crevices before and joins before the painting is done, and they found them to be a bast fiber, although I think subsequently others have found specifically identified it as hemp, but we didn't get as far as hemp, only to bast. So I was saying our choice of adhesive really was, this is our ideal adhesive, is going to be stable, something that's not going to deteriorate over time, is going to continue to be sticky, something that's reversible, ideally, it's hard to really reverse something that's in there, that's going to stay flexible upon drying. It's going to be suitable in a humid climate, so it's not going to attract bugs, and it is not going to turn to gel. So, and we also had issues in both rooms with the viscosity, because some of the flaking was very thick, heavy ajami that required one kind of adhesive, and some was very thin flakes of paint that required something less viscous. So we ended up using two different adhesives in both rooms. The fourth phase was loss compensation. So again, two more interns came. And this is just an example of one of they made a decision that about 7 feet down, they would do loss compensation to the point where they would fill the missing ajami, because you could see those differences in texture if you didn't do that. But above 7 feet, they just toned the losses so the white gesso didn't show from a distance. So there's a certain economy in the decision making. So these are the two interns of that summer. And that summer we had a different supervisor, Brian Body, on the right. I do need to acknowledge all of these people because it's their pictures, it's their reports that I've gleaned for this talk. So some of the big issues besides missing ajami that they dealt with here in the loss compensation was there are many areas where the varnish was really dark and all of a sudden really light. So it was not just between boards, but sometimes within one scheme. On the right, you see a very, very cloudy surface because of the varnish. Some layer of the varnish there had become blanched, probably because of the humidity in the air or the salt or something. And then on the bottom picture, you see the varnish, that dark, dark varnish is not all there. It's broken up, it's flaked away, so it looks kind of odd. So they did a lot of darkening some light things and lightening some dark things to kind of pull the room together. The ceiling took 2 years, really, 2 summers, but phase 1 was to do the assessment and start the consolidation. And Kirsten and Leanne mapped it just as the first interns mapped the Damascus Room, recording different kinds of condition issues like cracking, splitting of the wood, flaking of the ajami, and obvious overpaint that was done by, we think, by this campaign. And so this is an example of their Adobe Illustrator map, which then the next group of volunteers could come through and follow because it was not a one summer job. So this is Leanne Barnes on the top and Kirsten Travers on the bottom. And they put it together, this map, to keep track of their work, and it's pretty easy to follow. They're very methodical. And this was there. They used a slightly different key, color key, because the problems there were slightly different than in here. And the consolidants that we just chose to use were different there because we needed to stick with things that were not going to be really stinky and smelly. So we found again that water, it was really important to have some water in the adhesive because it softened the ajami and allowed us to set it down. And it was very easy to reverse or clean up after ourselves if we were using water instead of solvents. So these are just some of the condition issues: flaking, great images. This is a thinner kind of paint that was flaking, and then the cracking in the substrate. And also interesting things like gecko eggs and cobwebs. So the cleaning here was really limited to surface cleaning and dusting. We didn't even attempt to do any varnish removal. And I'll talk about that a little bit later when we look at Kirsten's technical study. So this is just a really nice example of before, when the ajami's practically falling off the wall, and injecting the adhesive with syringes often to get, and then you didn't even need to use heat, you could just slowly put it back up, and it seems to be holding. And this is the thinner kind of flaking. Sometimes these are just glazes that are flaking off the tin leaf, and it was very, very hard to get them down evenly, but so this was what was done in that first summer.
Wow.
And they left that record for the next summer. So this is just documentation and consolidation, no loss compensation. So the next team came in. Oh, and before I go on to the next team, Kirsten then during that summer took a lot of samples, decided to do her technical study. One of the third year requirements of the course is that you do a technical study of some art objects. So she was interested in architectural paint surfaces. So she took a lot of samples in addition to the ones that had been taken before the project. And I just wanted to show you a little bit of what she found. And this is just one area that she sampled. She did a lot of samples from. And this is just directly from her technical study. So she took it a step beyond what Richard Wolbers had done with this room. And she used other methods. She used gas chromatography, mass spectroscopy, which is much more specific about binding media. And she found, and she did some pigment analysis as well, using elemental analysis and polarized light microscopy. So this, again, we have another sample of blue with these really chunky, glassy blue, typical of smalt, but she actually did the analysis and found cobalt and silicon, the things that prove that it's smalt. And I have it right here, but I can't read it. And she also found, using GCMS, that she had proteins and drying oils, but specifically an egg protein, because you can look at the specific amino acids in GCMS. And so this is the first time, so this didn't happen here. I guess the point I want to make is we didn't really do full binding media analysis in this room. So we don't understand this room as well as we understand that ceiling, because she was able to do that technical analysis. And then so this is the GCMS. She also did cross sections using the biofluorescent dyes. So on the top, she's looking for a specific reaction for proteins, and on the bottom, a specific reaction for oils. But you really need to back that up with some analysis, and she did a really nice job with that. So this is interesting. She then did an Adobe Photoshop estimation of how bright it would be. And we've seen real reconstructions that Mecca's paper showed us, and it's pretty cool. There's really no hope of ever getting back to that in the condition that this is in. There's so much tin corrosion on the ceiling, so much flaking away of those glazing layers, that this one I think would be pretty tough to bring back. It's just so damaged. But And this is one of the most interesting findings, which mirrors what Mecca Baumeister found at the Met in their Damascus room, is that she found in one section where the later layers of varnish, and you see these two blue arrows, have actually solubilized the first layer, the original varnish, and it's sort of seeping up through it. So we definitely have an interactive zone in that ceiling, at least in this one sample, likely throughout the ceiling, that makes cleaning a little more dicey. Possibly possible, but it makes it pause. I should say that we've never seen a cross-section, and all the cross-sections that were taken here, I've never seen that interactive zone in the Damascus room. I saw that one where the varnish went down, but I never saw that intermingling like that. And I imagine if it was a long time before it happened, that it might not have happened. So this is just, again, the cleaning on the, and look how bright those colors are if you get up close to that ceiling. We just did surface cleaning and stabilization again. And then the second crew came in the following summer and finished up the consolidation and did in-painting and loss compensation on the entire ceiling, including some structural elements that had come off. We found something interesting. I had heard or read that Doris Duke really liked Krylon, which is a spray on acrylic. And when we were repairing the mirrors, we found that the mirrors looked really dull, and turned out that they were covered with what was probably Krylon. It looked sprayed. So we cleaned that off and peeled that off. And it made me wonder if there mustn't be some Krylon on the ceiling as well. It never showed up in the cross sections, but it always looked like plastic up there. I don't know. And then the second group did all of the in-painting. And again, because it's so far away, we didn't fill the ajami. We just touched up that bright, bright white so that from the distance you couldn't see it. And then these two interns, Stephanie Oman and Sarah Goen, finished the ceiling. And so before the summer was over, they were able to tackle the gilded mirrored doors, which were in pretty serious condition because of a termite infestation, only a few years after it was installed. I think she was away for a while, and somebody didn't notice the frass, and they really had their way with this whole gilded door. So they did some great work consolidating these really friable surfaces. Actually, the termites just tunneled through those ornaments, if you go look at that room, and they were hollow, and some places it had broken through. So using, after the termite infestation, these had been treated by someone from the bishop. I think that was a regional center at the time. And we had records from that, so we knew what they used. So we used the same material so it would be compatible, and tried to use some minimally invasive kinds of structural repairs using Japanese tissue.